Welcome to Get Your FRQ On. This question is from the 1998 exam. It's question 1, and it is calculator active. The question introduces a region R bounded between the graphs of y equals the square root of x, the x-axis, and then the vertical lines x equals 0 and x equals 4. And for references, this is the region R in question. In part A, we are asked to find the area of the region R. Okay, this is a fairly simple definite integral problem. The area is the integral from 0 to 4 of our function, which is the square root of x dx, which we can write as the integral from 0 to 4 of x to the 1/2 dx, and then use the power rule. That would be 2/3 of x to the 3/2 evaluated between 0 and 4. This is a calculator active question, so you could do this on a calculator. I didn't. You don't need to use a calculator for this. If you just set up the definite integral and evaluate it at the two limits, eventually we get 16/3. So that would be the area of the region R. In part B, we are asked to find a value of h such that the line x equals h divides R in half in terms of its area. And so what we're after here is, since the original area was 16/3, we want to find a value of h where either the integral from 0 to h is half of 16/3 or the integral from h to 4 is 8/3. Either one doesn't matter. So we take half of 16/3, that is 8/3. And so now we have a new equation. 8/3 is the integral from 0 to h of x to the 1/2 dx. Again, it's a definite integral. Like, we can find the antiderivative here. That's 2/3 of h to the 3/2. We would need that to be evaluated at 0 and h. At 0, it's pretty obvious what that would be. The antiderivative value at 0 is 0, so we plug in the h, and we get 8/3 would have to equal 2/3 of h to the 3/2. Solving that equation, right, so 8/3 is equal to 2/3 of h to the 3/2. That implies that 4 is equal to h to the 3/2. Solving for h, h is the cube root of 4 squared, or just the cube root of 16. All right, now again, this is calculator active, so some of this stuff you can use your calculator for. I opted not to. Part C, we are asked to find the volume of the solid of revolution of the region R, and this would be over the x-axis. We're revolving around the x-axis here. While the formula for the solid of a revolution, the volume of a solid of revolution, is pi times the integral from a to b of the function that generates the radius, f of x squared dx. So we substitute in our values. The volume is pi times the integral from 0 to 4 of x to the 1/2 squared dx. Well, x to the 1/2 squared is just x, so we have pi times the integral from 0 to 4 of x dx, which, when we evaluate that, we get 8 pi. So the volume of the region R, when we revolve it around the x-axis, is 8 pi. And in part D, similar to part B, we are asked to find a value of k such that the vertical line x equals k divides the solid of revolution for R in half. And we're going to approach this kind of the same way. We know that the volume of that solid of revolution is 8 pi. We want it to be half of that. So we set it equal to 4 pi. And then we set up an integral equation. Right? 4 pi is equal to pi times the integral from 0 to k of x dx. And we can figure out what that will be. 1/2 k squared minus 0 times pi. We don't know what k is, so we can't come up with a number for this, but we do know in the end we want it to equal 4 pi. So if we set up the equation, 4 pi equals k squared pi over 2, that means that 8 is equal to k squared, and therefore k is the square root of 8. And since we aren't considering negative values for R or x that in this region where R is defined, we don't have to worry about the negative version of square root 8 showing up. We know it's only going to be the positive version. So k is the square root of 8.